There are two sides. So here is what I call M1, here is what I call M2. Apparently you know it will go this way. It won't go this way. Why? Because here is heavier.
Yeah.
There are more mass and then it will go here. And then the second step is we need to find the center of the mass. For M1, where is the center of the mass? It's in the middle, right? The gravity will be like this. And in this side, the gravity will also in the center, pointing down.
Right.
But through the axis, apparently this side has a larger torque, so it will go down, right? But that's how I call torque 1 and torque 2. So we know the force here is M2G and here is M1G. But the R, what is the R? What is R? R is from the force to the axis, no? And we know here is 25 centimeters. So here will be half of the 25. Because the force is in the middle. Do you understand?
So you divide
25 by 2.
and you get point.
124 or 125. So here is the R.
Okay. And how did you do the second one?
The second one will be the same because here is 0.775 and half of it will be 0.375. So what I mean is half of
Because you did
belongs here.
Because they gave us 25 centimeters, so you do from 25 to the end of the stick
Yeah, will be 75.
will be 75.
Yeah.
And then you do half of
Half
70,
of the
75. Okay.
will be from the center of mass of this second part to the axis.
I get it. Keep going.
Okay. And then
So we have the R. So it's M2G.
we have the R1 and R2, right? There will be R2.
So we right here. It's M2G times R2 minus M2G, M1G.
R2 minus M1G R1 will be times the, we need to calculate this, right? So it will be M2G times R2, M1G times R1 over the moment of ignition. But we know every number right now. It's M2. You know how to calculate M1, M2? Because we know here is M1. And here is M2. M1 is 1/4. 1/4 of the total M. Right? Because it's 0.25. And the total one is 100. And it's uniform. It's a uniform stick. So it will be 1/4 of the total mass. And M2, which have 0.75. The long so is 0.75. You will have 3/4 of the total mass. And then we know R.
0.75 is 3/4.
0.75 is 3/4. Yeah.
And 0.25.
It's 1/4.
Okay.
Yeah. But you can use the numbers. It's the same thing. What I want to say is you can plug in those numbers and then.
But won't it be times G? M1, it'll be 1/4G.
1.
You have 1/4M.
I mean the M will be 1/4. The total mass.
Okay.
Okay.
But the
So
calculations would be 3/4G times R2.
3/4 M times G times R2. Yeah, you just need to plug in this here. And you have M, and the moment initial you have M, because they didn't give you the mass, the mass of the whole thing, right? Because that's why you need to have this M, and then you will cancel everything.
Oh, okay. So the M's going to cancel.
Yeah, the M will get canceled, no matter how heavy is the meter stick. The initial angular acceleration will be always the same. Because you get canceled. And then if you calculate 16.8, so the answer will be A. This one is a little bit complicated, so you need to take some time to draw and to.
I just have to remember how to do from here to here and there to there.
Yeah,
I
how
have
to
to
find
remember.
the center of the mass, the center of the mass, and then find the R. That's the most important thing for you to remember. So, and then you will be able to calculate the total torque, and then it's equal to moment of inertia times the initial angular acceleration.
Okay.
Okay.
You can keep going.
This one is the most difficult one, I think, for this questions. And the next one. Identical particles are placed at. Okay. 50 centimeter. And to avoid confusion, we can directly put to meter. It's 0.5 meter, 0.8 meter. So there is a meter stick, and then you have two particles. We don't know the weight. We can give to a mass M, and the meter stick, the mass of the meter stick is negligible. So that one, you'll have axis here, and then it will, if you release it, it will start to rotate. Right? Because you have these two. And then eventually it will rotate to here, to the bottom. And then it will through the lowest position. So rotate here, rotate, go to here. So the question is,